In this video, we'll add and subtract rational expressions. Exactly like rational numbers, we have two situations where we add rational expressions with the same denominators. So remember, this is numerator, this is denominator. So if these denominators are the same, we just copy the denominator and we add numerators. So let's take a look at the first example. 3 over 2x plus 1 plus 5x over 2x plus 1. Because the denominator is the same, we just copy it. And we add the numerators, which are 3 plus 5x. Or we can write 5x plus 3, just so that we are consistent with the denominator. So 5x plus 3 over 2x plus 1, and that's the final answer. Let's take a look at the example 2, where we have x squared over x minus 4 minus x plus 12 over x minus 4. Again, the denominators are the same, so we copy the denominator, x minus 4, and we subtract the numerators. So we have x squared minus the quantity x plus 12. So that means we copy x minus 4, and when we subtract the numerator, we have x squared minus x minus 12, right? This negative is distributed to each term. So we copy the denominator and we factor the numerator because maybe we have a common factor with the x minus 4. So we're looking for two numbers that have the sum -1 and product -12. The two numbers are -4 and 3. So the numerator is x minus 4 times x plus 3. So we notice that x minus 4 cancels with x minus 4, which is 1. So we end up just with x plus 3. So the final answer of example 2 is x plus 3. Now let's talk about different denominators. So if we have to add or subtract fractions or rational expressions that have different denominators. So remember how you did that when you had fractions, numbers. So we have to discuss least common denominator. So to find the least common denominator, you have first to factor all denominators. So get them in the simplest form, and then multiply all the factors raised to the highest power. So let's take a look at this example. Find the LCD of x cubed plus 3x squared plus 2x and 3x to the 4th. So first thing, we have to factor all denominators or factor all the expressions that you have. So let's deal with x cubed plus 3x squared plus 2x. We can factor x out of all the terms, so we end up with x squared plus 3x plus 2. Then we are looking for two numbers that have the sum 3 and the product 2. So the two numbers are 1 and 2. That means x times x plus 1 times x plus 2 are the factors of the first term from here. Now 3x to the 4th, the green one, it's already in factored form. So now the LCD is multiply all the factors. So the factors of the yellow one are x plus 1, x plus 2. And the factors of the green one are 3x to the 4th. So let's start with the constant. 3, it's a factor. Then I have x here, x to the 4th, and I have x here. So between the two of them, we choose the highest one, right? X to the 1st and x to the 4th, we copy x to the 4th. And then the other factors are x plus 1 and x plus 2. So the LCD of the two terms that we had is 3x to the 4th, x plus 1, x plus 2. Now, looking at the steps about adding and subtracting rational expressions, let's add and subtract the rational expressions below. So let's talk about example 1. 3 over 7b plus 4 over b squared. So we notice that we have different denominators. So the first thing that we want to do is factor the denominators of each rational expression. And if we look at the denominators, they are already in factored form. Now let's find the LCD. So the LCD let's write it here. LCD of 7b and b squared, well, it's all the factors, so it's 7 and b, but between b to the first and b to the second, we copy the highest one, so it's 7b to the second. So now, once we identify the LCD, rewrite each rational expression as an equivalent expression with the LCD at its denominator. So the first fraction, to have 7b squared at the denominator, we need to multiply it by b over b, because that way 7b times b, it's 7b squared. The second fraction needs a 7 to end up with 7b squared. So now the numerator of the first fraction is 3b, the denominator is 7b squared, plus the second fraction is 4 times 7, 28 over 7b squared. So now our fractions have the same denominators, so we just add the numerator. So 3b plus 28 over 7b squared is the sum of the two fractions. I cannot factor any further, we cannot simplify, so this is the final answer. Let's continue by solving example 2. So the first step that we want to do is factor the denominators completely. So 3t minus 2 over, and we want to find the factors of t squared plus 4t minus 12. So we are looking for two numbers that have the sum 4 and the product negative 12. And those numbers are negative 6 and 2. Let's see. Well, when we add them, we get negative 4. So let's put 6 and negative 2. So we have t plus 6 times t minus 2 minus 5 over, we factor 2 out and we get 2 times t plus 6. So now that we have everything in factored form, we have to find the LCD. So LCD of t plus 6 times t minus 2 and 2 times t plus 6, well, it's all the factors to the highest power. So 2 it's a factor, t plus 6 it's a factor, and t minus 2 it's a factor. So this is the LCD. Now, what do we need to do to the first fraction to have the denominator the LCD? Well, we need to multiply by 2. The second fraction needs to be multiplied by t minus 2 over t minus 2. So then, the first fraction becomes 6t minus 4, right? We multiply by 2 every single term, over 2 times t plus 6 times t minus 2, minus 5 times t minus 2 over 2 times t plus 6 times t minus 2. So now we notice how the common factor is the same. So I'm going to write it down. So, sorry, not the common factor, the denominator. So it's 2 times t plus 6 times t minus 2. And the numerator is 6t minus 4. And then minus in front of the parentheses changes all the signs. So negative 5 times t is negative 5t. Negative 5 times negative 2, it's plus 10. So add like terms, 6t minus 5t is t. Negative 4 minus 10 is plus 6. And the denominator is 2 times t plus 6 times t minus 2. And we notice that this quantity t plus 6 is the same with the factor t plus 6 from the denominator. So the whole t plus 6 cancels with t plus 6 and we are left with 1 at the numerator. So we end up with 1 over 2 times t minus 2. This is the final answer of example 2. Let's solve example 3. So we have 2 over x plus x over x plus 3, they are in factor form, these denominators, minus 3x plus 18 over x times x plus 3. So we factored this denominator because it wasn't in factor form. Now looking at all the denominators, let's find LCD of x plus 3. and x times x plus 3. So the LCD is multiply all the factors. So the factors are x plus 3, then x times x plus 3, right? So it's x times x plus 3. This is the LCD, and be careful, put parentheses around x plus 3 because otherwise it's something else. So how do we get from 2 over x to have the denominator x plus 3? Or in other words, I have this, what else is missing? It's missing x plus 3. So I'm going to multiply by x plus 3 over x plus 3. Top, bottom, I put around parentheses. Now I have x plus 3. I need x to have the same denominator, the LCD x times x plus 3. And then the last one already has x times x plus 3, so I don't have to make any changes. So this becomes 2 times x plus 3 plus x times x, which is x squared, minus the quantity 3x plus 18, everything over x times x plus 3, because now the denominator is the same. So we get 2x plus 6, because 2 times x, 2 times 3, plus x squared, and then negative 1 in front of the parentheses is negative 3x minus 18, everything over x times x plus 3. So this equals 2. Well, x squared is by itself, it doesn't have a like term. 2x minus 3x is negative x, and 6 minus 18 is negative 12. Everything over x times x plus 3. So let's factor the numerator, because maybe we have common factors with the denominator. So I'm looking for two numbers that have the sum negative 1 and product negative 12. How about negative 4 and 3? So we get x minus 4 times x plus 3 over x times x plus 3. So we notice the x plus 3 quantity, which when we divide we get 1. So we end up with x minus 4 over x, final answer of problem 3. And now let's solve problem 4. So notice that the denominator is x minus y and y minus x, and we had that conversation before, right? X minus y versus y minus x. Well, y minus x, it's actually negative x minus y. So y minus x is exactly the opposite of x minus y. So that means this becomes x squared over x minus y minus y squared over x minus y, right? Because y minus x is the opposite, so that's why I put minus here, of x minus y. So now we do have the same denominator, so I'm going to copy the denominator, x minus y, and then x squared minus y squared. But x squared minus y squared is a difference of squares. It's x minus y, x plus y, over x minus y. X minus y with x minus y cancel, and we get 1 at the numerator and the denominator. So x plus y is the final answer of example 4.